Jai Hind everyone. My name is Mamta Pant and I'm working as an assistant professor in IT department of Ajay Kumar Garg Engineering College, Ghaziabad. In the video series of DBMS, today we are going to discuss time stamping ordering protocol. What is this protocol? What does it mean? How we check that our given schedule is in this protocol or not? All the things we will discuss in this video lecture. Let's start it. So time stamping based protocol. What is this? Why we use time stamp based protocol and why we use the protocol? So basically till now we have studied about the transaction. Till now we have studied the transactions T1, T2, T3, such kind of transaction we have studied till now. These transactions combinedly make together a schedule. Okay, when we run more than one transaction at the very same time, then they make a schedule and their order is known as serializable schedule. The order of the transaction in which they are executed in the system is known as the serializable schedule. Okay, now we have checked that whether this schedule is in conflict mode, is a conflict serializable, view serializable, recoverable or not. So in concurrency control protocol, we basically try to make some schedules which are never going to the inconsistent state. So basically in concurrency control techniques, we try to make the schedules which are given the output in a consistent state, which contain our transaction in a consistent state. So basically timestamp based protocol is a concurrency control techniques protocol. So the basic idea of time stamping is to decide the order between the transactions before that enters into the system. So basically what does it mean? Whenever, suppose we have a transaction Ti, whenever these transactions enter into the system, we assign an order, a number, a sequence number, whatever it was, we have to assign an order to this transaction Ti. This transaction, this order, this number is known as timestamp or basically stamp of a transaction. So this is the idea of the time stamping based protocol. Whenever a transaction enter into the system, we need to assign a number, an order and stamping to that transaction. Why we do so? So that in case of conflict during the execution, we can resolve the conflict using the order. What does it mean? It means that if we have two transactions T1 and T2, suppose transaction T1 comes at number 1 and transaction T2 comes at number 2. These are the stamping of these two transactions. Now, if we find any conflict during the execution, if both of the transactions, that in case of conflict, transaction T1 executed before transaction T2. Why? Because its stamping is lesser than the stamping of transaction T2. So it is the meaning of this statement. Next, the reason we call timestamp, because for stamping we use the value of system clock. Now what does it mean? It means whenever a transaction come into the system, we assign a number to that and it is called as stamping of the transaction. And why we call timestamp? Because suppose if we are using the number for assigning the stamping to a transaction, then we have to put a counter on the memory so that it may increment every time when a new transaction is coming into the system. So to overcome all these problems, we basically use the system clock. We basically use system clock for using stamping of the transaction. Why? Because it will always be unique. The time of a system clock along with its date is always be unique and can never be repeat itself. So basically system clock is used as date plus time. So this timestamp will be unique always for every and each transaction and can never be repeat itself. So that's why we use system clock. Next, for each transaction, Ti is issued timestamp TS of Ti when it enters into the system. Whenever a transaction enter into a system, we set a timestamp for the transaction and denoted by timestamp of transaction Ti. Each transaction has a unique timestamp because we need to resolve the conflict depending upon their timestamp. Newer transactions have a timestamp strictly greater than the earlier ones. Whenever a new transaction enters into a system, it will get a greater timestamp than the previous one. Next, the timestamp could be based on a logical counter. Real time may not be unique and can use wall clock time logical counter to ensure. Okay. Next is timestamp based protocol manage concurrent transactions. What does it mean? It means our serializability order is depending upon the timestamp order of the transaction. Suppose we have two transactions T1 and T2. If T1 has lesser timestamp than T2, then T1 will execute it first and after that T1 will be executed. Several alternative protocols based on this timestamp. Depending upon this idea of time stamping, we have different protocols, and one of them is time stamping based ordering protocol. Here in time stamping based ordering protocol, we basically have two ideas or two timestamp. We have two timestamp values. First one is timestamp of transaction or timestamp with transaction. Next one is the timestamp with data item. We have two types of timestamps. One is for transaction and other one is for the data items. Next is first one, timestamp with transaction. With each transaction Ti, we associate a timestamp denoted by Ts of Ti. Now from where this value is coming? It is the value of system clock, date plus time when a transaction enter the system. So if a new transaction Tj enter into a system, then it must satisfy this condition. If Ti enter first, its timestamp, suppose it have 5 timestamp. So the transaction whoever comes after the transaction Ti have greater timestamp than Ti. It will have 10, 15 and so on, but it should be greater than 5. Next, the timestamp of transaction always be unique and will remain fixed throughout the execution. You can take it as like your date of birth. Every person has a single date of birth. So, such that every transaction has a single timestamp. If you need second date of birth, you need to rebirth again. You need to die and then rebirth, then you get a new date of birth. So that in such a way, if a transaction want to have a new timestamp that it need to get out from the system and re-enter into the system to get the new timestamp. So the timestamp will remain fixed through the execution of the transaction. It also determines the serializability order. If timestamp of transaction Ti is less than timestamp of transaction Tj, then the system ensures that resultant conflict serializable schedule Ti will get executed first before Tj. If we have two transactions Ti and Tj and it will have timestamp 5, it will have timestamp 10. So all the executions of Ti will be first and it will execute second depending upon their timestamp. Next is timestamp with data item. Now next timestamp is associated with every data item, every resources a system have. For each data item, queue protocol maintains two timestamp value. We have two operation for every transaction, read or write. So we have two timestamp, one for read and other one for the write. One is your write timestamp. Now what is that write timestamp? It is also denoted by write timestamp of queue. What is this timestamp? It is the largest timestamp of any transaction that executed write queue successfully. Now, what does it mean? Suppose if we have 3 transactions, T1, T2 and T3 and queue is our data item. Suppose we have read queue, write queue and then write queue. So, the write timestamp of data item Q will be the timestamp of transaction T3. So, the transaction who recently update the data item, the timestamp of that transaction is assigned to the write timestamp of Q. Now, what is the read timestamp? Same as write timestamp. It is the largest timestamp of every transaction that executed read successfully. The transaction who executed read Q, give their timestamp to the read timestamp. It is also denoted by read timestamp of Q. Initially, the values of write timestamp and read timestamp will be null. It will be null. It will be null. Depending upon the transaction who is performing read or write operation on data item Q, these will be updated. Imposes rules on read and write operation to ensure that we have to impose some rules to ensure that any conflicting operations are executed in timestamp order. If there is any conflict, we have to resolve it depending upon their timestamp. Out of the order operations cause transactions rollback. If some transactions come out of the order, then we need to roll back that transaction. We need to abort that transaction and re-enter the transaction into the system. Next, so these were the timestamp. Now, two cases arise with the timestamp ordering protocol. Case 1, if a transaction TI request for read data item Q, and next case would be if a transaction TI request for writing a data item Q. These two cases arise. Every transaction is two operation, read or write. So we have here two cases. A transaction TI request either for read, either for write. Consider the case number 1, that is TI request for read Q. Here two further cases are arise. First case, if timestamp, we have three timestamp now. Timestamp of TI who is requesting for read or write operation, and write timestamp of Q, and read timestamp of Q. In this scenario, we have three timestamps. So, the first case, if the timestamp of TI is less than write timestamp of Q, what we have to do in such kind of situation? So, let's take an example. Let's take an example. This is the transaction. This is our schedule where transaction is executing. Okay. So, what this case is, let's suppose timestamp of TI is 5 and write timestamp of Q is 10. Let's suppose any number. These 5 and 10 satisfy this condition. 5 is less than 10. So, we can consider these values. So, what would be the scenario in schedule? Timestamp of TI. Here is a transaction TI whose timestamp is 5. Okay, and some transaction who recently perform a write operation on data item Q. Suppose it is any transaction. Suppose it is TX and it has the timestamp 10 and it perform write Q operation. This is the case. This is the example. Okay. Now, what transaction TI want? Transaction TI request for read Q. Now this transaction wanted to read Q. So this is the basically scenario of case 1. But when we studied about the timestamp based protocol, we have studied that the lesser timestamp, the transaction having the lesser timestamp will perform operations before the transaction who have greater timestamp. So this read operation should be performed here. Here should be performed because its timestamp is lesser than the timestamp of TX. But when the transaction TI should ignore the time when it comes to the read operation. At the meanwhile, some transaction TX come into the system and perform a write Q operation, and now TI wanted to read the data item. So this violates the timestamp on conflict serializability rules. It violates completely. So we need to reject this transaction and we need to roll back. This read operation cannot be performed. Why? Because we have timestamp lesser than the timestamp of TX. So hence, read operation is rejected and TI is rollback. This is the scenario. Next, consider case number 2. In this case number, where timestamp of TI is greater than is equals to write timestamp of Q. Here we have two scenarios. One is greater than, one is equals to. So first take greater than timestamp of ti, timestamp of x. Suppose this is 10 and now this is 5. Timestamp of ti is 10 and a transaction who recently updated data item q have timestamp of 5. Here we have performed read q. Now operation is coming read q. Ti has greater timestamp, so we can perform this operation clearly. So this read operation is executed and read timestamp is set to the read timestamp of q, or timestamp, whatever value will be the maximum, will be assigned to the read timestamp of the q. And next scenario is where timestamp of ti is equals to write timestamp of q. Here is a transaction ti, here is a transaction t2. This case will be when the transaction who perform write operation on data item q again wanted to read the data item q. This will be the case. So in this case also transaction is executed and read timestamp is set to the maximum of read timestamp of q transaction ti. Next, ti is a request for write q. Here we have 4 conditions. First one is write timestamp of ti is less than read timestamp of. So this is the scenario. We have transaction ti and some another transaction tx. Ti has timestamp suppose 5. Suppose this is 5 and this is 10. And a transaction whose timestamp is 10 perform the read q operation. After this read q operation, ti wanted to perform write q. So depending upon the transaction, we cannot perform this operation. So we need to reject this transaction and we need to roll back. Let's take another case, timestamp of this. Here we have timestamp of ti is suppose 5 and some transaction tx has timestamp of 10. We have performed write q and after that ti wanted to rewrite on q. This comes earlier into the system, so it need to perform before tx. So this transaction is also rejected and transaction ti should be rolled back. Write operation is rejected and ti is rolled back. And other 2 cases where timestamp of ti is greater than is equals to read timestamp of q, and other condition is timestamp of ti is greater than is equals to write timestamp of q. In both of these conditions, we have to execute the write operation and updated write timestamp accordingly. Next, here is some examples of timestamp ordering protocol. Is this schedule under timestamping ordering protocol? So basically, you can clearly see that read B operation is performed before this. Its timestamp is 25, its timestamp is 26. So read B performed before T26 and read A performed. So this is perfectly a timestamp ordering protocol. Let's see another example. In this example, its timestamp is 27, its timestamp is 28. Basically, this write queue operation should be done before T28, but this is happen after T28. So this transaction is rejected and should be rolled back. Transaction number 27. Next, this is another example of timestamp ordering protocol. You can clearly see this is read X. It should perform before this transaction T5. So this should be aborted due to the violation of timestamping ordering protocol, and this is also have the violation of timestamping based protocol. So we need to abort them and roll back into the system. Here is some properties about the timestamping ordering protocol. We have some properties. What are these? It ensure conflict serializability. And next is it ensure view serializability. Means the schedules we get with these protocols, they are conflict serializable and also view serializable. Next is there is some possibility of dirty read operation. What is the dirty read? Reading the uncommitted data is known as dirty read problem. Why this is so? Because there is no restriction on commit operations. Next, irrecoverable schedule and cascading rollbacks are possible here. Here, either we allow or reject, there is no chances of deadlock. So here, we either allow the transaction to execute it or roll back to the transaction. So there is no chances of hold and wait. So there is no chances of deadlock. But it may suffer from this starvation and it is relatively slow than any other protocols we are using in concurrency control techniques. Here one property is also there. If we make a schedule depending upon timestamp based protocol, it is conflict serializable. Next one is why the correctness of timestamping ordering protocol. Timestamping ordering protocol guarantees serializability. Reason: transaction with smaller timestamp have an edge to the transaction with larger timestamp. So there is never be the possibility of making a cycle in the precedence graph. So there should never be any conflict operations would be there. Timestamp based protocol is ensure freedom from deadlock, because no cycle will be formed into the precedence graph. So there is no chances of deadlock situations. But schedule may be cascade free and not even recoverable. Means we can get irrecoverable schedule from timestamping ordering protocol. So what are the solution for this, so that we can get recoverable and cascadeless free schedule? The solution is a transaction is structured such that its writes are performed at the end of the processing. All write operations should perform at the very end of the transactions. Next, all write of a transaction form an atomic action. Means whenever a transaction performing any write operation, all transactions should hold their operations. Next, a transaction that aborts it's restarted with a new timestamp. Whenever a transaction re-enter into a system, it will get a new timestamp greater than the previous transaction. So now it may executed its operation successfully. The next solution is limited form of locking. Wait for the data to be committed before reading it. And the third solution is use commit dependency to ensure recoverability. We need to take care of when our transaction will be committed or not. Next is your Thomas Wright rule. What is the Thomas Wright rule? We have considered a situation. Suppose here we take a situation. We have a transaction Ti and another transaction Tx. We have timestamp of transaction Ti 5, and suppose we have timestamp of transaction Tx is 10. Now let's suppose a situation that here we have transaction Ti wanted to perform write operation on data item Q, but when its time come, it may ignore the chances, and in the meanwhile another transaction come into the system and perform write Q operation. Now transaction wanted to write on data item Q. Now let's suppose the scenario. This is the example of blind write. What is the meaning of blind write here? Blind write is writing a value without reading it. Blind write is writing any value without reading it is known as blind write. So this is the situation of blind write. Suppose transaction Ti wanted to update the value of Q is 25. Suppose here if it come first and it will update to 25. And now transaction Tx updated it to 30. Because it is blind write, there is no need to read its data items Q's value. So does this really affect this write operation? No. The answer is no. This write operation really does not affect this write operation. So if it is happened or not doesn't affect the transaction Tx write Q operation. So in this case, what we will do in timestamp ordering protocol, what we said that this transaction could not be performed, we need to reject and roll back the transaction. But in Thomas Wright rule, what Thomas Wright rule said that instead of rollback, we just ignore this. Instead of rolling back or aborting the transaction, we need to ignore this operation and we continue with the other process. This is the Thomas Wright rule and updation of timestamp ordering protocol. So there's the take one by one points. Modified version of the timestamp ordering protocol in which absolute write operation may be ignored. Only absolute write, that is the value which is written by the blind write operation under certain circumstances. When Ti attempts to write data item Q, if timestamp of Ti is less than write timestamp of Q, then Ti is attempting to write an absolute value of q. In this case, timestamping ordering protocol roll back the transaction, reject the transaction and roll back into the system. But rather than rolling back, timestamp ordering protocol would have done the write operation can be ignored and we can process for the further. Otherwise, this protocol is same as the timestamp ordering protocol. So, Thomas Wright rule basically allow greater potential concurrency, allow some view serializable schedule that are not conflict serializable schedule. So, thank you for today. We will see into the next video.